hopefully you're seeing my screen at this point. Thanks so much for having me, and I'm excited that so many people are interested and are here tonight. Yeah, so I'm here to share our work and our thinking about the multiple benefits of riparian zones and riparian ecosystem restoration, and sort of how that's informed a lot of the work that I'm doing right now in California. Before we dive into that, I wanted to start with just a little bit of background on Point Blue and where I'm coming from. So let's see here. Okay, so Point Blue Conservation Science is a nonprofit science organization. We're based in California, but we conduct international conservation research ranging from Alaska to Peru, from the Sierra Nevada mountains to our east, out to sea, out to the Farallon Islands to our west, and as far away as Antarctica. We have some folks who go study penguins every year. Our mission is to advance the conservation of birds, other wildlife, and ecosystems through science partnerships and outreach. So to that end, we work in partnership with government agencies, universities, other conservation organizations around the world. And we also have our own habitat restoration and education programs in-house. We were originally founded as the Point Reyes Bird Observatory, and we were really laser focused on bird conservation, but have expanded quite a bit since 1965. And speaking of bird conservation, that's where I'm coming from too. I'm a wildlife ecologist. This is me in about 2004, just starting out as a new field biologist, learning how to capture and handle birds, ranging from the red-tailed hawk on the right on what was a very windy day, to the Steller's jay I'm holding on the left. And with all of this bird research, we're collecting data to track how bird populations are changing over time, how they're responding to things like restoration and climate change. So through these experiences, I found my passion in conservation research, and I learned how bird populations can be really great indicators of environmental conditions and of the ecosystems they rely on. And we know birds aren't doing well overall. You may have seen these results come out just a couple of years ago that found just since 1970, there are an estimated 2.9 billion with a B, billion fewer birds. We think largely due to habitat loss, degradation, and fragmentation. And of course, climate change is not helping. And so if birds are indicators of ecosystem condition, you know, they're the canaries in the coal mine. We know this is not just birds. There's real concern worldwide about the loss of biodiversity and habitat, and growing conservation and restoration efforts to reverse these trends. And in California, a major focus has been riparian ecosystem restoration, particularly in the Central Valley. And just to orient you all a little bit, this is San Francisco right here where I am right now, in San Francisco Bay, that you might be familiar with. And if you head east and inland, this great big flat area is what we call the Central Valley. And so it's kind of a bathtub, ringed by the Sierra Nevada mountains to the east and our Coast Range to the west. And the bright green you can see is the estimated extent of historical riparian vegetation from around 1850. And the dark green specks that you can barely see right in here, scattered throughout, that's the current extent of riparian vegetation. So we estimate, you know, over 95% of it has been lost. Since about the 1980s, there has been a significant effort to restore riparian vegetation, especially along the Sacramento River in the northern part of the Central Valley. And Point Blue has a long history of helping to support those efforts and study the wildlife response in particular. And we know that birds do respond quickly to riparian restoration. This is a graph showing the change in bird species richness with the age of the restoration project over time. And this is combined over a bunch of different restoration sites along the Sacramento River. And our assumption all along has been that if these birds are responding well to efforts like these, we assume the ecosystem health is also improving, And so there are probably many other benefits being provided by this restoration. And we wanted to be able to understand and talk about these other benefits because as great as I think birds are, I know not everyone is going to be motivated by bird conservation. So, we know there are many possible benefits of riparian conservation and restoration. And this is a cartoon I found illustrating some of these. But we were always talking about these other benefits in kind of a vague way as sort of a potential for improvement in things like water filtration and water quality, benefits to other wildlife, certainly stream temperatures and benefits to fish and other aquatic organisms. More recently, we've been talking more about the potential for carbon storage and improvements to the health and well-being of local communities of people. And over time, our thinking evolved from, wouldn't it be great if we could measure all of these benefits and really quantify the full comprehensive value of a riparian restoration project? Really make a good case for why it's worth investing in these projects. We kind of started there and evolved from there to, wouldn't it be even better if we could intentionally design our restoration projects to provide multiple benefits? So, what would that look like? Would the designs be different than what we're already doing right now? And what should those multiple benefits, what should those goals be? And also, who should be involved in defining those goals that we're maybe not working with yet? So these are certainly not just my ideas or Point Blue ideas. They've been around in the conservation world for a long time in different forms. But there was a new term floating around, multiple benefit conservation, that hadn't been clearly defined yet and was starting to get used in some different ways. And so we proposed a definition for multiple benefit conservation that we published in 2020. And this is conservation efforts designed to simultaneously benefit local communities of people, enhance ecological function, and improve the habitat quality for fish and wildlife. So the idea is that multiple goals are defined at the start of a project, and the project is specifically designed to achieve them all together, or at least try to. And this is in contrast to projects that, really have one primary goal. Maybe it's birds, maybe it's fish, maybe it's water quality, but there's really one primary goal that the project is designed for, and it might also produce some nice side effects, but they're not really part of the goal. So we wanted to distinguish those two ideas. And we described what we saw as several strengths of this multiple benefits approach. While it's not an entirely new concept, we think it's a constructive evolution of some existing approaches like win-win conservation and ecosystem services. But we think it can be more inclusive of multiple worldviews and values, in that goals can span the spectrum from ecological to societal benefits, really reflecting the values of the local community. And goals can be defined in terms of their own metrics. So they don't have to be put in terms of an economic value, which is something that many people, myself included, I think find very uncomfortable when it comes to defining the value of a species or an ecosystem. We think it's probably a more easily communicated concept than other terms like ecosystem services. And it's solutions oriented, in that when you define multiple goals at the outset of a project, it's encouraging collaboration and daylighting trade-offs and synergies among those goals. And with all of this, we think it can be compelling. We expect that this approach will create opportunities for more innovative partnerships and collaborations, potentially new funding sources, and ultimately result in more innovative projects. So this is a really appealing concept to me, but much easier said than done. It's certainly complicated. And so how do we take this concept from a sort of philosophical idea or ideal to something more real and something we can really do? So how can communities come together to define their multiple goals and understand the synergies and trade-offs among those goals, and ultimately make collaborative decisions that help achieve their goals. So I'm going to walk you through some of the projects we've been working on to support these ideas. And our first step was to try to document some of these benefits. So how strong is the evidence for them, and how large might these benefits be? We started with carbon because we are very concerned about climate change, and because of the growing conversations about the role of restoration in contributing to climate change mitigation. So you may be very familiar with this already, but the United Nations has launched the Decade on Ecosystem Restoration to draw attention and build momentum for this idea that restoration can address global crises of climate change and biodiversity conservation at the same time. And here's a couple of images from their social media campaign, one aimed at forests and the other aimed at rivers and wetlands. We find that riparian forests, which are both forests and wetlands, kind of fall in the gap and are sometimes left out of these conversations. They don't fit neatly into one category. So we wanted to see where riparian forests fall in the potential for carbon storage. And to start, we compiled data from all over the world and used it to model how much carbon, on average, is stored in riparian forests. And we found that carbon stocks in mature riparian forests, and this is just in the trees, rival that of any other biome. The blue bars are our estimates for riparian forests from 4 different climate zones. So we divided the data from around the world into warm and wet, warm and dry, cool and wet, cool and dry climate zones, and kind of modeled them separately. And so we have 4 different blue bars representing riparian zones, riparian forests, and then the gray bars are other estimates from the IPCC. Lots of carbon stored in the trees. We also found that planting riparian trees accelerated the process. So here I'm showing you how much carbon increased over the first 10 years of forest growth. The green bars are for naturally regenerating riparian forests. So these are places that are recovering from a fire or flood or some other disturbance. And the pink bars are forests that had been actively planted as part of a restoration. So not surprisingly, planting trees jump-started the forest growth, and the initial growth rates were more than double. Now, it doesn't mean that you necessarily end up with more carbon by the time the forests are mature. They kind of catch up at the end, but it gets things going faster. So this is all just in the trees. We also looked at the soil, and we found that soil carbon on average more than triples as a riparian forest is restored or recovers. It is a slow process. It can take over 100 years to reach that value, but it was a much larger increase than had previously been estimated. So our research provided good evidence that riparian forests do sequester carbon, and that restoration could be a good strategy for carbon sequestration, particularly when you consider all of the other potential benefits. But there is a concern that if carbon storage is your primary goal, a project designed to maximize carbon may not always be good for biodiversity. So, for example, there's a concern from people who work in prairie ecosystems that all of this enthusiasm for planting trees everywhere is not always the best strategy. So we need to consider the trade-offs. So for a riparian restoration project, if we had goals of both providing habitat for riparian birds and sequestering carbon, how strongly are those two goals related to each other? And are there any trade-offs? And how might we need to tweak the design of a restoration to meet both goals? So we conducted a field study. Again, we're here in the Central Valley of California, focused on the Cosumnes River Preserve. And this is an area that has some of the oldest remnant riparian forest in the Central Valley. The orange plot is the remnant forest that's at least 80 years old, and the blue and green plots on either side are very well-established restoration sites, each 20 to 30 years old. And we've been conducting research in the preserve since the mid-90s, but we went back specifically to look at this question of how birds and carbon are related to each other. And we compared these 3 mature riparian forests to a baseline site just a bit further upstream that was in the beginning stages of restoration. And just for a visual comparison, here is the baseline site on the left, which was a former cornfield and mostly devoid of any woody vegetation. And on the right is the mature remnant forest, at least 80 years old, very, very dense canopy and understory, very difficult to walk around in there. So by surveying the bird community and estimating the carbon stocks in each of these study areas, we found that, you won't be surprised, but we found that having any riparian forest at all was better than none. So the densities of riparian birds were at least 3 times higher in all of the mature forest sites compared to the baseline. And there were large increases in the carbon stocks as well in both the trees and the soil. So on one level, yes, there's a synergy between carbon storage and these bird conservation goals. But we also found that forest structure matters. So here's a sort of 3D graph showing forest density on the vertical axis. So this is the number of trees per unit area, and shrub cover is on the horizontal axis. So this is essentially how much understory is there. And the color filling in the graph is showing the predicted carbon stock for each combination of forest density and shrub cover. And yellow is the highest and dark purple the lowest. And so the white dots are showing you the combinations we observed at the different points we visited throughout the preserve. So what this is telling you is that if all you cared about was maximizing carbon, you wanted this yellow, we would want a lot of trees, more than they have in most places in the preserve. And we wouldn't really care how much shrub cover there was, because it doesn't really have much impact on carbon stocks, so we might not bother planting it. But the same graph for bird abundance showed a very different pattern. They seem to prefer a more open, less dense forest with fewer trees and more understory. And now this graph is for all birds combined, all species combined. So we might have a slightly different pattern for different species, but just to give you a sense of the overall trend. So if we were only looking at the graph on the right, and we only cared about birds, we would recommend designing restorations with a high shrub cover, maybe ensuring the forest doesn't get too dense. So what this means is that we also have some evidence for a trade-off here. We can't get the yellow, we can't maximize both carbon and birds at the same time in the same place. And so how riparian restoration projects are designed and managed has a real impact on how much of a carbon versus biodiversity benefit we get. So this research is really just the tip of the iceberg. All I've talked about so far is birds and carbon. But the idea is that this kind of information can help support planning and implementation of multiple benefit conservation projects across multiple goals. So here's just kind of a simple example of how we might use this information or communicate this information. Let's say we have a plot of land, or maybe it's an entire watershed, and we're considering a couple of different restoration scenarios. And this could be different restoration designs or methods or spatial configurations. And we have so far just those 2 goals of increasing carbon storage and riparian bird habitat. We expect restoration would increase both, but maybe how much depends on which design you choose. You can imagine incorporating additional goals, additional rows in this table, or additional scenarios to consider, which might do a better or worse job of meeting these goals. But the idea here is to help, communicate where the synergies and trade-offs are and which scenarios would help achieve multiple benefits. So with this in mind, my work has proceeded from this point in a couple of different directions. And one is developing an integrated protocol for studying multiple benefits in riparian sites. And the idea is that you would be able to quantify multiple benefits in a way that would let you see how they relate to each other. So if this is a riparian site we want to study, maybe it's a restoration site, there's a stream running through it. Excuse my kind of bad drawings. We can conduct bird surveys to see how the bird community responds. We can also set up transects throughout the study area to overlay information about the vegetation structure and composition and the carbon stocks in the trees. And we can also collect data on soil health. So metrics like the soil bulk density, or a measure of soil compaction, water infiltration rates, and soil carbon. And we can see how these multiple dimensions of the ecosystem change over time, how they relate to each other, and maybe how they compare to other sites that might vary in restoration design or geography or other factors. So we've tested this out at a few sites and have drafted a protocol that I think some of you have seen. And it would be great to have other folks test this out, send us feedback, maybe even add new metrics to it. And we can start putting together a larger data set so we can understand these relationships better. And then the second direction this work has taken is applying these concepts on a broader scale. So going beyond just riparian systems to consider entire landscapes and a much broader suite of community values. So I wanted to share a bit about this project, which is focused on the Sacramento-San Joaquin Delta in California, but which I think is applicable to other landscape scale planning efforts. And just for a little orientation to the Delta, in case you're not familiar, the Delta is this area outlined in black here. And again, here's San Francisco and San Francisco Bay. And if you travel upstream, you run into the confluence of the Sacramento River coming down from the north and the San Joaquin River coming up from the south. They meet here in this vast inland delta. The water flows out through the bay and out through the Golden Gate. And this area historically would have been mostly marsh. It's now mostly agricultural land. The kind of land cover layer you're seeing here, agricultural land is in tan, the kind of tan color. There are some natural land covers still, some riparian, some wetlands, some tidal marsh, interestingly freshwater tidal marsh, as well as several urban areas in kind of the dark gray. And this area is super important in California for a number of reasons. In terms of water supply and water quality, the Delta conveys water from the wetter Northern California to farmers and communities in the Delta, but also water actually gets pumped south to the southern part of the Central Valley. And then water is also needed to flow west out to the San Francisco Bay to limit saltwater intrusion. And then ecologically, these channels are also super important for salmon that are migrating through here. There's also a protected freshwater fish species, the Delta smelt, and a number of other aquatic organisms. This area is also a really important location on the Pacific Flyway for migratory birds. And as a result, it's a hotspot for wildlife watching and for waterfowl hunters as well. At the same time, the peat soils built up from the historic marshes have made for very rich farmland. But drying them out and farming them has also resulted in substantial greenhouse gas emissions and incredible subsidence. So the soil is compacting so much that many of these islands are now well below sea level and at increased risk of flooding if a levee were to break or just with sea level rise. So there's a ton of interest in this area from people who live and work in the Delta, but also from throughout California because of its importance. And the state has defined two main goals for management of the Delta, described as co-equal goals of providing a more reliable water supply for California and also protecting, restoring, and enhancing the Delta ecosystem. So essentially we have defined multiple goals we want to achieve simultaneously, but more than that, these goals are intended to be achieved in a manner that protects and enhances the unique cultural, recreational, natural resource, and agricultural values of the Delta as an evolving place. So this is incredibly ambitious and complicated. And here's a simplified conceptual model in which, if we're aiming for a thriving Delta, it's one that would support these multiple kind of overlapping values But the Delta's landscape is evolving through many processes, including habitat restoration, crop conversions, urban development, and sea level rise. These changes to the landscape are potentially influencing many of these values, and therefore how well we can meet our goal of a thriving Delta. And so the goals of this project have been to try to understand the relationships between the current landscape and metrics representing some of these values. So can we predict how different land covers are related to these values? Use this information to forecast the net impacts of different scenarios of landscape change, and then ultimately generalize this process to develop a flexible framework for evaluating scenarios of landscape change and really finding a way to understand and communicate the co-benefits and trade-offs of kind of alternative land management decisions. And I do not pretend that providing this information will solve everything or solve anything, but I do think there is value in getting everyone on the same page to understand what the trade-offs are of alternative decisions. So for ecological values, we of course look to our strength in studying the extent of available bird habitat as kind of establishing the foundations of this framework. So we used data from 2,500 bird surveys to build spatial distribution models for a bunch of different species that nest in the Delta. And here are a few examples showing the predicted probability of each species being present, with the highest probability shown in red and the lowest in blue. And you can see that the results vary quite a bit depending on which species you look at. They're all responding to different features and different configurations of the landscape. And these models will allow us to forecast how we expect each species to shift in response to future landscape changes. But to this, we're also adding things like metrics around agricultural livelihoods. So agricultural jobs and wages and crop production value. And you can see, big differences across land cover classes. In this area, orchards tend to employ far more people per area harvested and also have relatively high production value. Although this is gross production value, so it doesn't account for costs. But the idea here is that just as with the spatial distribution models, this kind of information can help us estimate the change in each of these metrics across scenarios. Similarly, we also examined pesticide application rates by land cover class as an indicator of the relative risk to water quality. So we looked at chemicals belonging to different groups. There's a group of critical pesticides, a group of known groundwater contaminants, and a group that they're known to pose a risk to aquatic organisms. And again, variation across land cover classes and crop types so that changes in the landscape might translate to more or fewer pesticides being applied. And so then we worked with partners to develop two fairly simple scenarios for the year 2050, each representing one major driver of landscape change. So the first scenario is a habitat restoration scenario, adding a lot more managed wetlands and riparian vegetation, wetlands in blue and riparian in red, to meet specific restoration targets that have been set out. And then scenario two is a scenario without any restoration, but the expansion of perennial crops continues at current rates. So there's this trend of annual crops getting converted to perennial crops. And in this case, we have three kind of subclasses: vineyards in purple, deciduous fruit and nut orchards in green, and then a little bit of citrus and subtropical orchards in orange. And so we looked at how the direction and magnitude of change in each metric would change for each scenario. And so these are brand new results. I've just finished drafting last week, literally. You're among the first to see these, and showing you just a subset of some of the metrics that we looked at. But the increases or benefits are shown in blue and decreases in orange. And so now we can identify some of the costs and benefits of each scenario and where there are trade-offs between metrics that change in opposite directions. So if you look at scenario one on the left, We see increases in habitat suitability are expected for most of the species we looked at. We also expect increases in water quality, meaning a reduction in pesticide application rates. But we also would expect a decrease in all of the agricultural livelihood metrics. And that's because we're converting some of the cropland to wetlands or riparian. And then in scenario 2, we see essentially the opposite. So these results, I think, would be intuitive to some people who are very familiar with these particular metrics or with these particular systems, but not everybody. And I think this kind of approach can support communication about these trade-offs. And by providing estimates of their magnitude can help support decision-making. And for goals that aren't fully compatible with each other, at least in the same time and place, it can help support proposing new scenarios that represent some sort of compromise or hold space for both of them in different places. So this project hasn't addressed carbon yet, but circling back to this idea of supporting collaborative planning and implementation, the next step in this project will be to share our results with partners across the Delta and also learn what other goals or benefits people would like this framework to include, like carbon stocks and greenhouse gas emissions. We kind of conceived of this as a phase 1, kind of a proof of concept and establishing the foundations, but the goal is to keep building on it in the future. And with this specific project, and with the concept of multiple benefit conservation in general, I have a vision of supporting creative new partnerships where community members can come together to collectively identify their goals, propose alternate scenarios, and ultimately make decisions together. And that the experts and the scientists can help by providing supporting information and analyses about how much each of those scenarios will contribute to their goals. Because I think it's really tough for anyone to understand or be able to intuit changes in all of these multiple dimensions at once. We all have our own perspectives and knowledge bases. And so finding ways to share that information and help everyone get on the same page seems really valuable. I recognize this is not easy stuff, but for me, it feels like a really positive and useful way forward. So thank you so much for listening and for the invitation to speak to you today. And I hope it's been useful or helpful to hear how we're thinking about multiple benefit conservation and riparian ecosystems in particular.
Great. Thank you, Kristen, for that. Yeah, that was really interesting. Just a couple comments so far. So just a reminder, if anyone does have any questions, you're getting lots of applauses on the Zoom there. That's the standing ovation. You just can't see it. Just a couple comments to start. I think early on, Margot commented that the kind of philosophy that you kind of laid out and the groundwork for this, she called that a fantastic philosophy. And I think it was the comparison of the cornfield and the riparian forest that Margaret said, that's a beautiful place. And I agree with that.
Cornfield, right?
She might have also been talking about the Consumnes Preserve in particular, which I've been to and would second that as being a very awesome spot to visit.
It is.
Okay. Yep. Margaret's saying that's where she used to hang out there when she lived in Sacramento. So
good.
So Margot asks, have you involved the indigenous cultures of those areas in the planning process?
Yeah, I mean, I will say I personally haven't worked extensively with indigenous groups. It is more and more an essential part of planning in California, and for sure there's another project I didn't talk about today that I'm involved with. It's another kind of planning project considering alternative scenarios, and they're a much more I would say structured format that is very intentionally including different sectors, and indigenous communities are a big part of that steering committee. it's absolutely essential. And I think one of the challenges is, just making space for different voices and recognizing that there are different values in different communities. And too often the goal setting is very narrowly framed around a limited set of metrics. And I think especially if it's all boiled down to economic value, it's really hard to represent other kinds of values. And so getting away from that is what I'm hoping to support.
Yeah, I give you a lot of credit for even trying to get all those different variables on the same page and mix them up together. It sounds head spinning for sure, but I agree with the previous comment, a beautiful philosophy, and cool to see that you're making real good traction and progress on it. So we have another question from Paul here. He asks, are your streams on the 303D list? / do they have water quality problems, and how best do you bring those streams into compliance? Buffer width, etc. Is that a priority?
Yeah, So in some places for sure, that is in some places the driving reason for a lot of the riparian restoration is around water quality and mitigating runoff impacts into different streams. It's an issue in the Delta for sure, although there it's like they're at the bottom of a giant watershed. So some of the critical pesticides that I was talking about are ones on that list. And how to bring them into compliance, it's so context dependent. But for sure, some of the smaller streams in where we've been testing this multiple benefits protocol, that's one of the primary drivers of, it's a lot of restoration on private land, and that's one of the primary drivers. So I don't know if I could speak to buffer widths in particular, but for sure riparian systems have such a role to play in protecting water quality.
Sure. All right, so Paul, we have like 37 Pauls here, so 2 of them have chimed in. This is Paul Caton. How do these changes impact pollinators, which are important for agricultural crop propagation? That's
a great question, and I don't have an answer. There are, I keep coming back to like, I'm a wildlife ecologist. I study birds, I study bird populations, and I feel sort of torn between staying in my lane and also needing all of this ecological research to be much more interdisciplinary. And so developing those partnerships and collaborations with other people who are experts in things like pollinators and pesticides and water quality is so essential. And I can't say that I always walk the talk or whatever the phrase is. For a lot of this, it's kind of like, let's test it out and see if this makes sense. And then hopefully we can build on it from here and bring in more folks.
Makes sense. Fran asks, there's a carbon market in California, correct? Does this influence the conversation and help meet multiple goals?
Yeah, so yeah, for sure there is a carbon market. There's actually a couple different ones. Some of them are very data intensive, very kind of strict. They require a lot of documentation. And some of them are a little bit less so, a little bit more forward-looking opportunities to kind of fund projects in advance. So there's a few different options, and for sure that was one of the reasons why we started looking into carbon is, is it a way to help fund restoration? And I think it hasn't quite panned out that way, at least yet. But I do think that the state has set these really ambitious kind of carbon mitigation offset goals. and they're increasingly recognizing the need for carbon sequestration on natural lands to be part of the equation. And so just by even documenting what the carbon benefits could be of some of these restoration projects, I think has had an influence. I hope has had an influence in kind of making, a lot of it I'll say is focused on the big coniferous forests in the Sierra, but bringing riparian forests into that conversation has been one of the goals.
Great. Well, that's it, but I'm gonna, there's a big one here from Debbie. Hold on one second. I'll read it off. We'll see where it goes. So this may be a little too far into the weeds, but I'm trying to understand the graphs you showed comparing carbon versus birds at the preserve. I was wondering about the white circles in particular. As I recall, there were only 2 in the upper section of those graphs. Are those sampling sites? If so, could that have been something to do with the results in the bird densities?
Yeah. I was like, I don't think I can pull it up real quick again, but yeah, absolutely. Those were two of the, I'm not going to remember off the top of my head how many sites we had. Those were individual sampling sites. 2 of them were in spots that were incredibly dense, and they were part of an area that had naturally regenerated. So these weren't planted trees, and they had come in so dense, and those spots had a lot of carbon, but not very many birds. And so for sure, those 2 points had an influence on the models, but we didn't let them have an outsized influence in the way we analyzed those data. But for sure, I think, this was not a huge study. We didn't have, a massive number of sampling points. I think it's something that for sure should be repeated in other places to see, if the patterns hold up, depending on where you are, which species you're looking at, and that kind of thing. But it was more of an example of, there had been these kind of really high level, kind of global efforts to identify biodiversity hotspots and like carbon potential, and sort of overlay these places. And there maybe still hasn't been very much on the ground comparisons and understanding these kind of interactions with forest structure or other kind of aspects of the ecosystem, how that's driving these 2 things that we're trying to accomplish at the same time.
So as a birder, I can't resist asking a bird focused question. I'll give you 2 options because that might be a tough one. So what's your favorite bird, or do you have a nemesis bird? So one that you've always tried to go and find but never been able to actually see in person.
Oh gosh.
You can answer either or both or neither if you really wanted to.
Well, my favorite bird has to be song sparrow, because it's what I spent my entire dissertation on. And I grew to really appreciate these, from a distance, kind of plain brown birds, but up close, absolutely gorgeous with incredible songs, and sneaky and smart, very difficult to find their nests. Really appreciate them. I don't know if I have any nemesis birds. I'm not a hardcore birder. I disappoint people when I say that, but I appreciate them all.
That's a good answer. All right. Well, I think that's it for questions. Trevor, anything else from you?
No, that's okay. I'll pass.
All right. Well, thank you, Kristen. That was really great, and from all the smiles and clapping, I think everyone else enjoyed it as well. So, thanks for taking the time this evening, and really interesting work, and we're excited to hear about it. And I think keep in touch as well. We'd like to kind of carry on with you and see where this goes and your next steps, and try to incorporate some of this kind of monitoring work into the work we do too, to kind of assess the impacts and how we could do better and work on those trade-offs. So thanks a lot. Thanks for joining us.
Yeah, sounds great. Thanks for having me, and great to see you all. And I just see Annie, and I'll say hi to Annie. We were in grad school together.
Nice. Right. Small world.
Yeah.
Right on.
But yeah, thanks. Great questions, and really appreciate the invitation. Hope
Great.
to work with you guys again.